Hi, I'm Bob. We will continue our solutions to the exercises for the short-run costs in Chapter 7. Let's solve exercise 2.7. Gail works in a flower shop where she produces 10 floral arrangements per hour. She is paid $10 an hour for the first 8 hours she works, and $15 an hour for each additional hour. What is the firm's cost function? What are its average cost, average variable cost, and marginal cost functions? Draw the average cost, average variable cost, and marginal cost curves. Her hours of work are the variable input, so there's only the variable cost for the production. If she works for 8 hours or less, the total cost and the variable cost are the same. C equals VC equals Q, where Q is the number of floral arrangements. The marginal cost, the average variable cost, and the average cost are $1. If she works for more than 8 hours, the cost function and the variable cost function are the same. 80 plus 1.5 times the difference between Q and 80. There is only variable input in this case. The average cost and the average variable cost are the same. 1.5 minus 40 divided by Q. The marginal cost is 1.5. The total cost curve and the variable cost curve are identical in the upper graph. The marginal cost curve is horizontal. The average cost and the average variable cost are identical and have a kink. Let's find answers to 2.8. In 1796, Gottfried Christoph Hartel, a German music publisher, calculated the cost of printing music using an engraved plate technology and used this estimated cost function to make production decisions. Hartel figured that the fixed cost of printing a musical page, the cost of engraving the plates, was 900 pfennigs. The marginal cost of each additional copy of the page was 5 pfennigs. In Part A, graph the total cost, average variable cost, and marginal cost functions. We calculate the average cost, the average variable cost, and the marginal cost. The curves are as follows. In Part B, would the cost be lower if only one music publisher prints a given composition? Yes, the fixed cost is 900 pfennigs. If there's only one music publisher, the average fixed cost falls as more units of output are produced, because the fixed cost is spread over more units. If there were 2 publishers, each publisher has to incur 900 pfennigs as the fixed cost. For a given composition, the average cost would be lower with only one music publisher. For Part C, Hartel used his data to do the following type of analysis. Suppose he expected to sell exactly 300 copies of a composition at 15 pfennigs per page. What is the highest price the publisher would be willing to pay the composer per page of the composition if he wants to at least break even? The revenue is 4,500 pfennigs. The total cost of producing 300 pages is the sum of the fixed cost and the variable cost, 2,400 pfennigs. The publisher can pay 2,100 pfennigs to the composer, that is 7 pfennigs per page, if he wants to break even. Let's do exercise 2.9. A Chinese high-technology firm has a production function as follows. It faces factor prices of W equals 10 and R equals 20. What are its short-run, marginal, and average variable cost curves? In the short run, capital is fixed. We can write the short-run production function as Q equals 10 times A times L to the power 0.28, where A represents the fixed capital. Rearranging this expression, we write the number of workers L needed to produce Q unit of output as a function of output. The variable cost equals wage times the number of workers. From the variable cost function, we can derive the marginal cost and the average variable cost functions. They are functions of the units of output Q. Suppose the capital is fixed at 1 unit. We can calculate the marginal cost and the average variable cost and draw the curves. I leave the Stata command for the graph in the description below. Please check out my Stata courses on my YouTube channel if you are interested. Let's solve exercise 2.10. A Japanese synthetic rubber manufacturer's production function is a Cobb-Douglas function. Suppose that its wage is $1 per hour and the rental cost of capital is $4. In part A, draw an accurate figure showing how the synthetic rubber manufacturer minimizes its cost of production. In part B, what is the equation for the long-run expansion path for the manufacturer, illustrated in a graph? In the long run, the cost-minimizing combination of inputs is determined by the tangency between the isoquant and the isocost line. At the point of tangency, the slope of the isoquant equals the slope of the isocost line. The slope of the isoquant is the marginal rate of technical substitution, which is the negative of the ratio of the marginal product of labor to the marginal product of capital. It equals minus K over L. The slope of the isocost line is the negative of the price ratio of labor to capital. The two slopes are the same, so we have the expansion path equation. K equals L over 4. In part C, derive the long-run total cost curve equation as a function of Q. Using the expansion path equation and the production function, we can write the output as a function of labor, Then we can express labor as a function of units of output. Finally, we write the long-run total cost in terms of the unit of output Q. Let's do exercise 2.11. A firm has two plants that produce identical output. The cost functions are as follows. In part A, at what output level does the average cost curve of each plant reach its minimum? We derive the average cost function of plant 1 and use the first order condition to find the output level that minimizes the average cost. It is 2. The second order condition for a minimum is satisfied. Similarly, the output level is 1, which minimizes the average cost of plant 2. For part B, if the firm wants to produce 4 units of output, how much should it produce in each plant? When plant 1 produces 2 units of output, its total cost is 12, and its average cost is 6. When plant 2 produces 1 unit of output, its total cost is 9 and its average cost is also 9. The 4th unit of output should be produced in plant 1 because its average cost is lower. When plant 1 produces 3 units of output, its cost is 21 and its average cost is 7. The total cost of the 4 units of output is 30. Let's find answers to exercise 2.12. We have the estimated short-run cost function of a Japanese beer manufacturer. At what positive quantity does the average cost function reach its minimum? If a $400 lump sum tax is applied to the firm, at what positive quantity is the after-tax average cost minimized? In the first step, we derive the average cost function and the marginal cost function from the total cost function. In the second step, we use the fact that the marginal cost curve cuts the average cost curve at its minimum to find the units of output that minimize the average cost. It is around 23 units. In the third step, we rewrite the total cost function with the lump sum tax. By the same method, we equate the marginal cost and the average cost to find the output that minimizes the average cost. But I'm not sure how to solve the final equation. Let's solve exercise 2.13. What is the effect of a lump sum franchise tax on the quantity at which a firm's after-tax average cost curve reaches its minimum, given that the firm's before-tax average cost curve is U-shaped? The lump sum tax T raises the fixed cost by that amount. The average cost will increase by T over Q for each output level. The average cost curve moves upward from ACB to ACA. The marginal cost curve is not affected by the lump sum tax. It is unchanged. The output level that minimizes the average cost will increase from QB to QA. Let's go to exercise 2.14. Platinum Pipeline Incorporated needs a dozer to install water and sewer lines. How does its fixed cost change if it can rent a dozer rather than buy one? The sharing economy changes the fixed input to variable input because the company can rent the dozer instead of owning it. Thank you for solving all the exercises with me in this section. See you in the next part of the chapter. Goodbye. Thank you for watching this video and subscribing to my YouTube channel. See you next time.